prevent backfeeding the electrical grid when connecting a generator, it's crucial to isolate the house electrical system. A correct setup involves disconnecting the feed wires from the main breaker and connecting the generator to that breaker. This ensures that the generator's power does not flow back into the grid. The appropriate wire size for feeding the breaker from the generator depends on the amperage of both the generator and the distance between the generator and the breaker. As a general guideline, for a 100 amps breaker and a generator with an amperage capacity of 50 amps or greater, a 6 American wire gauge wire is typically sufficient. However, always consult local electrical codes and regulations to ensure compliance. An automatic transfer switch, or ATS, can be installed to automate the process of switching between grid power and generator power. The ATS should be placed between the generator and the house electrical system. When the grid power fails, the ATS automatically transfers the load to the generator. This provides a seamless transition and ensures that essential appliances and systems continue to operate without interruption. The ATS must be rated for the amperage of the generator and have an appropriate transfer time to prevent damage to sensitive electronics. A slow transfer time can cause voltage dips or surges, which can be harmful to sensitive equipment. To set up an ATS, firstly, install the ATS between the generator and the house electrical panel. Secondly, connect the generator to the ATS. Thirdly, connect the house electrical panel to the ATS. Fourthly, configure the ATS settings to automatically transfer power when the grid power fails. Fifthly, test the ATS by simulating a grid power outage to ensure it functions correctly. Firstly, you need to install the automatic transfer switch between the generator and the house's electrical panel. This is a crucial step as the ATS acts as the intermediary, managing the power source for the house. Secondly, after the ATS is in place, connect the generator to the ATS. This connection allows the generator to feed power into the ATS. Thirdly, connect the house electrical panel to the ATS. This connection allows the ATS to distribute power from either the grid or the generator to the house. Fourthly, configure the ATS settings to automatically transfer power when the grid power fails. The ATS needs to be programmed to detect a power outage and initiate the transfer to generator power. Fifthly, it's important to test the ATS by simulating a grid power outage to ensure it functions correctly. This ensures that the system will work as expected during a real power outage. Several additional points are worth noting. Firstly, always use high-quality materials when connecting the generator and ATS. This ensures the reliability and longevity of the system. Secondly, follow all electrical codes and regulations. Compliance with these codes is essential for safety and legality. Thirdly, ensure the generator is properly grounded. Grounding protects against electrical shock and equipment damage. Fourthly, the generator should be placed outside in a well-ventilated area, away from windows and doors. This prevents the buildup of carbon monoxide, which is a deadly gas. Fifthly, never connect a generator directly to the electrical grid without an ATS or other approved transfer device. Direct connection can cause backfeeding, which can be dangerous and illegal. When selecting an ATS, consider the following factors. The amperage rating of the ATS should match or exceed the amperage rating of the generator. This ensures that the ATS can handle the full load of the generator. The transfer time of the ATS should be as short as possible to minimize disruptions to power. A fast transfer time prevents sensitive electronics from being affected by voltage fluctuations. The ATS should have features such as voltage monitoring, frequency monitoring, and overload protection. These features protect the generator and the electrical system from damage. The ATS should be easy to install and configure. A user-friendly interface makes the installation process smoother and reduces the risk of errors. Before installing a generator and ATS, it is recommended to consult with a qualified electrician. An electrician can assess the electrical system and ensure that the installation is safe and compliant with all applicable codes. The electrician can also provide guidance on selecting the appropriate generator and ATS for the specific needs of the house. During the installation process, it is important to follow all safety precautions. Wear appropriate personal protective equipment, such as gloves and safety glasses. Disconnect the power to the electrical panel before working on any electrical connections. Double check all connections to ensure they are tight and secure. After the installation is complete, thoroughly test the system to ensure it is functioning correctly. Simulate a power outage to verify that the ATS automatically transfers power to the generator. Monitor the generator's performance to ensure it is providing stable power. Regularly inspect the generator and ATS to identify any potential problems. Check for loose connections, damaged wires, or signs of corrosion. Perform regular maintenance on the generator, such as changing the oil and filter. Keep the generator clean and free of debris. By following these guidelines, you can safely and effectively connect a generator to your home's electrical system and ensure a reliable source of backup power during outages. Remember that electrical work can be dangerous, so it is always best to consult with a qualified electrician if you are not comfortable performing the installation yourself. Always prioritize safety and adhere to all applicable codes and regulations. Understanding the NEC, or National Electrical Code, is very important. The NEC provides comprehensive guidelines for electrical installations, including those involving generators and transfer switches. Some key NEC sections relevant to generator installations include: firstly, Article 700 covers emergency systems which are intended to provide power to essential loads during power outages. Secondly, Article 701 covers legally required standby systems, which are required by law to provide power to certain types of facilities, such as hospitals and fire stations. Thirdly, Article 702 covers optional standby systems, which are not legally required but provide backup power for non-essential loads. Fourthly, Article 705 covers interconnected electric power production sources, which includes generators that are connected to the electrical grid. Fifthly, Article 250 covers grounding and bonding, which are essential for electrical safety. These articles provide detailed requirements for the installation, wiring, and protection of generators and transfer switches. Adhering to the NEC ensures that the installation is safe and compliant with industry standards. It is important to consult the latest edition of the NEC and any applicable local amendments. The NEC is updated every 3 years, so it is essential to stay current with the latest requirements. In addition to the NEC, there may be local electrical codes and regulations that apply to generator installations. These codes may vary depending on the jurisdiction. It is important to check with the local building department or electrical inspector to determine the specific requirements in the area. Local codes may address issues such as permitting, inspections, and specific installation requirements. Compliance with local codes is essential for legal and safety reasons. When selecting a generator, it is important to consider the power requirements of the house. Determine the total wattage of all the appliances and devices that need to be powered during a power outage. This will help determine the appropriate size of the generator. It is also important to consider the starting wattage of certain appliances, such as air conditioners and refrigerators. These appliances require more power to start than they do to run. The generator should be able to handle the starting wattage of these appliances. Generators are available in a variety of sizes and types. Portable generators are smaller and more affordable, but they typically have less power capacity. Standby generators are larger and more expensive, but they can provide power to the entire house. Inverter generators are a type of portable generator that produces cleaner power, which is better for sensitive electronics. When selecting a generator, consider the following factors. The wattage rating of the generator should be sufficient to power all the essential appliances and devices. The fuel type of the generator should be readily available and affordable. The noise level of the generator should be acceptable. The portability of the generator should be suitable for your needs. The warranty of the generator should provide adequate protection. Once you have selected a generator, it is important to properly maintain it. Follow the manufacturer's instructions for maintenance and care. Change the oil regularly, clean the air filter, and inspect the spark plug. Store the generator in a dry, protected location. By properly maintaining the generator, you can ensure that it will be ready to provide power when you need it. Understanding generator output, there are a few concepts to keep in mind. Generators produce electrical power, which is measured in watts. Watts are the product of volts and amps. The formula for calculating watts is watts equals volts times amps. For example, a 120 volts appliance that draws 10 amps consumes 1200 watts of power. Generators are typically rated in watts or kilowatts, where 1 kilowatt equals 1000 watts. It is important to choose a generator with a wattage rating that is sufficient to power all the essential appliances and devices. It is also important to consider the voltage of the generator. Most homes in the United States are wired for 120 volts and 240 volts. Some appliances, such as lights and small appliances, operate on 120 volts. Other appliances, such as ovens and air conditioners, operate on 240 volts. The generator should be able to provide both 120 volts and 240 volts power. Generators typically have multiple outlets for connecting appliances and devices. Some outlets are designed for 120 volts, while others are designed for 240 volts. Be sure to use the correct outlet for the appliance or device being connected. Overloading a generator can damage the generator and the appliances connected to it. It is important to avoid exceeding the generator's wattage rating. If you are unsure of the wattage requirements of an appliance, consult the appliance's label or owner's manual. It is also important to use the correct size and type of extension cords. Extension cords that are too small can overheat and cause a fire. Extension cords that are too long can cause a voltage drop, which can damage appliances. Use heavy-duty extension cords that are rated for outdoor use. When using a generator, it is important to follow all safety precautions. Never operate a generator indoors or in an enclosed space. Generators produce carbon monoxide, which is a deadly gas. Always operate the generator in a well-ventilated area, away from windows and doors. Keep the generator dry and protected from the elements. Do not operate the generator in wet conditions. Before refueling the generator, turn it off and let it cool down. Gasoline is flammable and can ignite if spilled on a hot engine. Wear appropriate personal protective equipment, such as gloves and safety glasses. By following these safety precautions, you can safely operate a generator and avoid potential hazards. Considering grounding, it plays a vital role in electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Generators should always be properly grounded. The grounding requirements for generators are specified in the NEC. The NEC requires that generators be grounded to a grounding electrode system. A grounding electrode system is a system of interconnected grounding electrodes, such as ground rods, ground plates, and metal water pipes. The grounding electrode system provides a low-impedance path for fault current to flow back to the source. The size of the grounding conductor depends on the size of the generator. The grounding conductor should be sized according to NEC Table 250.122. The grounding conductor should be connected to the generator's grounding terminal. The grounding terminal is typically located on the generator's frame. The grounding conductor should also be connected to the grounding electrode system. The connection to the grounding electrode system should be made at a readily accessible location. In some cases, it may be necessary to install a separate grounding electrode system for the generator. This is typically required if the generator is located a significant distance from the existing grounding electrode system. A separate grounding electrode system should consist of at least one ground rod. The ground rod should be driven into the earth to a depth of at least 8 feet. The ground rod should be made of copper or copper-clad steel. The grounding conductor should be connected to the ground rod using a grounding clamp. It is important to ensure that the grounding connections are tight and secure. Loose grounding connections can compromise the effectiveness of the grounding system. Regularly inspect the grounding connections to ensure they are in good condition. If you are unsure of the grounding requirements for your generator, consult with a qualified electrician. An electrician can assess the site and ensure that the generator is properly grounded. Improper grounding can create a serious electrical hazard. By properly grounding the generator, you can protect yourself and others from electrical shock. When dealing with wire sizing, there are certain aspects that are essential to know. The correct wire size is crucial for ensuring the safe and efficient operation of the generator. Wires that are too small can overheat and cause a fire. Wires that are too large are unnecessary and can add to the cost of the installation. The wire size depends on the amperage of the generator and the distance from the generator to the load. The longer the distance, the larger the wire size required. The wire size is typically specified in American wire gauge. The smaller the American wire gauge number, the larger the wire size. For example, a 12 American wire gauge wire is smaller than a 10 American wire gauge wire. The wire size should be selected according to NEC Table 310.15b16. This table provides the ampacity of various wire sizes based on the insulation type and the ambient temperature. The ampacity of the wire should be equal to or greater than the amperage of the generator. It is also important to consider the voltage drop in the wires. Voltage drop is the reduction in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause appliances to malfunction. The voltage drop should be limited to 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using the following formula: voltage drop equals 2 times length times current times resistance divided by 1000, where length is the length of the wire in feet, current is the current in amps, and resistance is the resistance of the wire in ohms per 1000 feet. The resistance of the wire can be found in NEC Chapter 9, Table 8. If the voltage drop is excessive, the wire size should be increased. It is also important to use the correct type of wire for the application. Wires are available with different insulation types, such as THHN, THWN, and XHHW. The insulation type should be suitable for the environment in which the wire will be installed. For example, THHN wire is suitable for dry locations, while THWN wire is suitable for wet locations. The wire should also be rated for the voltage and temperature of the application. Use high-quality wire that is listed by a recognized testing laboratory, such as Underwriters Laboratories. When connecting wires, use the correct size and type of connectors. Wire connectors should be properly installed and tightened. Loose wire connections can cause overheating and electrical hazards. It is also important to protect the wires from damage. Wires should be run in conduit or cable trays to protect them from physical damage. Wires should be properly supported to prevent them from sagging. By following these guidelines, you can select the correct wire size and type for your generator installation and ensure the safe and efficient operation of the system. And to review what to do in the event of a power outage. Firstly, ensure the generator is placed outside and away from any windows and doors. Secondly, make sure the generator is on a level surface. Thirdly, check the oil and fuel levels before starting the generator. Fourthly, start the generator according to the manufacturer's instructions. Fifthly, allow the generator to warm up for a few minutes before connecting any loads. Sixthly, turn off all major appliances and lights before connecting the generator to the electrical panel. Seventhly, switch the main breaker to the off position to isolate the house from the grid. Eighthly, connect the generator to the electrical panel using a transfer switch. Ninthly, turn on the circuit breakers for the essential appliances and lights. Tenthly, monitor the generator's performance and make sure it is running smoothly. 11thly, avoid overloading the generator by connecting too many appliances at once. 12thly, when power is restored, turn off the circuit breakers for the generator. 13thly, switch the main breaker to the on position. 14thly, disconnect the generator from the electrical panel. 15thly, allow the generator to cool down before storing it. 16thly, store the generator in a dry and well-ventilated location. 17thly, perform regular maintenance on the generator to keep it in good working condition. 18thly, test the generator periodically to ensure it is ready to use in the event of a power outage. Lastly, by following these steps, you can safely and effectively use the generator during a power outage.